Okay, so a little musical introduction, a little song from Led Zeppelin. All right, so what we're going to be doing is transformations here, and I'm going to look at, the first one we're going to look at is what we call a vertical shift. That's when we take an elementary function and move it up and down. All right, so what we're going to do is we're going to graph absolute value of x plus 3, but to begin with, we're only going to do the elementary function. So if we do the absolute value of each of these numbers, which we've already done, and you can do this in your head, that just gives you 1, 0, 1, 2. I'm doing the absolute value of each of those numbers. Now what we're going to do is we're going to go ahead and plot those. Okay, so go ahead and do that. You got negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. And then just fill that in with a dashed line. Be sure you put that double arrow at the end of it. Okay, and then let's label that as f of x equals absolute value of x. Okay, well, what we do is we add 3 to this. So what this 3 does is it just adds 3 to these y values. Okay, so all these things here get bigger by 3. So we do 2 plus 3 is 5. We do 1 plus 3 is 4. 0 plus 3 is 3, and so forth. All right, so these things are all getting bigger by 3, so we get that, and we're going to plot these points. Now, when we plot these points, we're doing negative 2, 5, negative 1, 4, 0, 3, 1, 4, and 2, 5. So we're plotting all those points. So we got negative 2, 5, like that, negative 1, 4, 0, 3, 1, 4, and 2, 5. All right, and then that will give you the graph, the final graph that we're looking for. So what this did is that plus 3 transformed or moved all those points up 3 units. Okay, so this is the graph of y equals absolute value of x plus 3. Okay, so that thing right there just moved you up 3. All right, so I'm going to do an example that I'm going to start you off on the next one here. You can pause anytime you need on these videos, as you remember. Okay, so I'm going to go ahead and take you through here, and I'm going to tell you what numbers to use on this. So the first thing we're going to do is we're only going to graph this. And remember, you can't do a square root of a negative. You can do a square root of 0. And then you want to pick some numbers that are perfect squares. I'm going to give you this number, and that number. So what I want you to do is fill this out, graph the square root of x in like a dashed line, and then use like a solid line on this, and then do that. And then I want you to complete these 2 problems. I want you to tell me what you think the minus 10 does and what you think the plus 5 does as far as transformations. Okay, so go ahead and pause the video, work out that first graph, and then answer these 2 questions here. Come back and check when you're ready. All right, so go ahead and check and see if you got everything filled out right. The table, this would be your points, 0, 0, 1, 1, 4, 2, 9, 3. So your graph of the elementary function square root of x should look like that. And then everything went down 2. So what you're doing is taking these y values and subtracting 2. So 0 minus 2 is negative 2. 1 minus 2 is negative 1. 2 minus 2 is 0. 3 minus 2 is 1. So basically everything just moved down 2 points. two values downward, all the y's did, so that would be what your final graph looks like. And basically on this, what you're learning is if you have a plus, that's going to take you up, the y values go up. And if that's a minus, the y values go down. So hopefully you got that. That's down 10 because it's minus, that's plus 5, moves the graph up 5. So that's the first type of transformation. Okay, so let's move to the next page, and now we'll do a horizontal shift. Horizontal shifts are sometimes a little harder for students to see how they work. So I will go through and do one of these and let you try one of these too yourself so you can get the hang of this. So what we're going to do is we're going to graph this function. And the x minus 3 is inside of the function. Okay, it's inside of the squaring operation. And it turns out it all depends on where that number is as to where it moves it. Sometimes it moves up, down. Sometimes it moves left, right. So the first thing we're going to do is we're going to forget about the 3 and just do x squared. And again, it's okay if you do this in your head. I'm just going to do negative 2 squared would be 4. Negative 1 squared would be 1. 0 squared is 0. 1 to the second is 1. 2 to the second is 4. 3 to the second is 9, and 4 to the second is 16. Most of those things you're going to do in your head. So we're going to go ahead and plot these points to begin with. So we have negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and then we'll go ahead and go to the point 3, 9, just kind of move up one additional notch like that, and that's good enough. And then just go ahead and sketch that in, labeling that as f of x equals x to the second. So that's an elementary squaring function is what we call that. So we get that. Now what we're going to do is we're actually just going to crunch this out because I want you to sort of see how this works. So what I'm going to do is plug in this number and work it out. Okay, and we're going to do this. So the negative 2 is going to go in there. So we're going to have negative 2 minus 3 to the second. Then we're going to plug negative 1 in. So we'll work out negative 1 minus 3 to the second. And plug 0 in and so forth. And we'll work these out. And we'll just try to do as many of these as we can in our head. Okay, so you want to go ahead and do that. It's a good idea to write all this down so that you can review what we did on this problem to get these new points, okay? So let's start up here. This would be negative 5 squared. So negative 5 squared is 25. So it's kind of hard to plot that point on here because it's kind of out of range. This one is negative 4 to the second. So that's positive 16. This one is negative 3 to the second. So it's 9. This one is negative 2 to the second, so that's 4. You'll start kind of seeing a pattern on this. This is negative 1 to the second, which is 1. This is 0 to the second, which is 0. And the last one's 1 to the second, which is 1. So we'll plot, as many of these points as we can. Let's just kind of forget about, this one and just focus on plotting these. So again, I'm doing the x value and the y value. So I'm highlighting the points that I'm plotting so we can kind of discover what happens on this. So let's start by plotting the point 0, 9, okay, and then the point 1, 4, then the point 2, 1, then the point 3, 0, and then finally the point 4, 1. And what I'm trying to do is kind of see if you can kind of discover for yourself what's happening on this graph. Now, if we continue this, if we went down to 5, if we did that, we'd do 5 minus 3 squared would be 2 squared, so we'd be at 4. So we can add a 0.54 if you want to. Gives us a little bit greater accuracy. So let's write this as f of x equals x minus 3 to the second. So I want you to look at those two graphs. What happened? Exactly. Okay, it looks like everything moved to the right 3 units. Okay, And you'll learn to realize that it's going to turn out, it's almost opposite of what it seems like it would be. But if that's a minus, then that'll go to the right 3. And see, that 3 has to be inside of the function. If it was x squared minus 3, that would be down 3. If it was x squared plus 3, that would be up 3. See, the 3 is outside of the function. It's outside of that squaring. So that's totally separate. But if it's inside, if you have x minus 3 squared, it turns out that goes to the right 3. So what do you think would happen if it was this way? Right, it would go left 3 like that. So that's the idea. Okay, that's how that goes. All right, so what I want you to do is I want you to try to fill this one out. Pause the video and try to fill this out and see if you can figure out what that plus 2 does. Again, that's inside of the absolute value. So we're looking at things moving left or right, okay? So go ahead and pause and then come back and check when you're ready to check. Okay, so go ahead and check over your calculations and just verify that you did these correctly. The first thing you have, of course, just doing the absolute value of these numbers, so you should get these numbers. That's the graph of the elementary function in red. You want to get to a point where you understand the absolute value looks like a U, not a U, a V, okay? And this thing right there, since it's plus, again, there's two things. It's inside the absolute value. It's inside the function. And then a plus is what causes that move to the left too. So you want to check all your calculations. And what you're going to notice on this is when you plot the points, you'll see everything on this red graph moved to the left too. Okay, so that's how that goes. All right, now down at the bottom of the page, this is sort of a summary. And so it says basically if you're inside the function, then a horizontal translation occurs. So if you had a minus, that would take you to the right. If you had a plus, that would move you to the left. Okay, so what is this going to do then? This is inside. What does the plus do? That would be left 1. And how about this one? Yeah, that's inside the square root. Minus moves you to the right 6. So this one takes you to the right 6. The first one is to the left 1. So you want to be really solid on how that works. Okay. All right. So now next thing we're going to do is move down to part C of this, and then we'll do what we call reflections. Okay, so let's see, on this we're going to just work out square roots again. So we'll have this. I'm going to start with just using numbers I know square roots of. Let's use 0, 1, 4, and 9. That's good enough. Okay, and what we'll do on this is we'll do a square root. We can just do this in our head. The square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Okay, so go ahead and plot those points. So we have 0, 0, 1, 1, 4, 2, and extend out to go to 9, 3. And then use a dashed line just to represent that this is the elementary function, f of x equals square root of x. Okay? Now what happens is this thing right here, that negative, is going to multiply. This is something you want to write down too. It's going to multiply all of the y values by -1, because you want to understand how the math works. You don't want to memorize that it's a reflection or up, down, left, right. You want to understand the y part of it, and then you're more likely to remember it. So this is a -1. This is really -1 times the square root of x. So you do -1 times 0, which is 0. -1 times 1. See, I'm multiplying these y values by the negative, so that's -1. This becomes -2. That becomes -3. Okay, so again, you're just multiplying those numbers by negative. Now, if we go plot these, again, I'm going to put together, that's the x value. This is the transformed y value. Then what you would have is 0, 0, 1, -1, 4, -2, and then 9, -3, like that. And then let's label that as f of x. equals negative square root of x. Okay, so what that did is we say that this reflected, we call this a reflection over the y-axis, or not the y-axis, teacher, the x-axis. Okay, that's the x-axis, that's the y-axis. Sometimes I can't talk and think at the same time, I find. Older I get, the worse I think it gets too. Okay, so that's how that works. So all that's doing is, since the y's change, and it flips everything over, okay? Whenever you flip a y value to its opposite value, it moves over the x-axis, okay? All right, so I'm going to kind of see if you guys can work this one out. I want to just see if you can discover this one for yourself. And if you make mistakes, just correct yourself. So I want you to fill out this table. First of all, just do x to the third using these x's, and then do this, okay? And I'll give you an example, kind of when you get to this second thing here, you know, the first thing you're going to do over here is just work out like negative 2 to the third, negative 1 to the third, and so forth. But when you get over here, it's going to go negative 2 to the third, negative 1 to the third, and so forth. So go ahead and work that out and see if you can see what happens on this problem. Okay? Okay, so if you did all your number crunching correctly, this is what you should have came up with. And sometimes students struggle a little bit with these negatives and raising them to a power. So when you're working out this row here, negative 2 to the third, again, is just negative 2 times negative 2 times negative 2, so that's negative 8. This one is negative 1, negative 1, negative 1, so it's negative 1, and so forth. Okay, so this is your elementary function, the one I've got in red. I just plotted those points. Okay, now what happens is the negatives inside the function. Again, it always depends on whether it's inside or outside of the function. So it goes like this. If you're really doing a negative 2 inside the parenthesis and then raising the third power. Well, a negative 2 is 2. 2 to the third's 8. So that sign ended up changing. A negative 1 is a 1. 1 to the third's positive 1. Negative 0, well, there isn't such thing as negative 0. It's just 0. 0 to the third is still 0. And then this one, again, we're just plugging that 1 in. So you'd have negative 1 to the third, which is negative 1. And if you plug 2 in, you get negative 2 to the third, which is negative 8. So it did this. So it reflected, but how did it reflect? Did it reflect over the y-axis or the x-axis? Yeah, it's the y-axis. Okay, so this one is a reflection over the y-axis. Okay, now again, you got to have strategies to help you remember this stuff. You have to understand, that's how I remember all this stuff, so I understand the number stuff going on. Okay, I understand what's happening. So what's happening is this is really doing this. Okay, that is changing x to an opposite. If anytime you change an x value to an opposite, it flips it over y. Okay, so see, anytime that's a 2, that's a negative 2. That's a 1, that's a negative 1. So that's what happened, is it changed x. The previous example changed y. So anytime that you change y values, then you flip over the x-axis. That's what you have to understand. So think about that a little bit. Okay, so this is sort of a summary that we have here, and then I'm going to have you do one other thing here. So it's basically like this. This is how reflections work, okay? If you're outside the function, then it reflects over the x-axis. So that would be this one, okay? Again, you're outside of that f of x. Y becomes opposite, you flip over the x-axis. If you're inside the function, it reflects over y. That's because x becomes opposite. So you want to again understand the difference between outside and inside. Okay, so the next thing I want you to try to do is tell me what the transformations of each of these are. Okay, and the possibilities are left, right, up, down, or reflect over x, reflect over y. That's what we've learned so far. So see how much of that you've got put together. You can refer back to previous examples if you have to, right? But try to think of inside, outside. If the transformation's inside, then it's either going to be left, right, or it could be, or it's a reflect over one of the axes. Okay, so think about whether it's inside or outside and see if that helps you a little bit. So pause, check when. Okay, so check and see if you got these right here. So this one is reflecting over the y-axis. That's because the negative is inside and x becomes opposite. Anytime x becomes opposite, you're moving this way. Over here, moving over the y-axis. This one, the negative's outside, so the y values change. That means the y's change from here to there. They reflect or move over the x-axis. Okay, if you add outside, that's up. If you subtract outside the function, that's down. If you subtract inside the function, that's right. And if you add inside the function, that's left. These are the ones that sometimes a little confusing for students. It doesn't seem that it would work that way, but it does work that way. We did an example to kind of show you how that works. Okay, so we'll go to the next thing, which is the stretching and shrinking. And let's go ahead and begin to go through that a little bit. Okay, now what we're going to do is we're going to put a number in front of the function. Okay, so we're going to just do a squaring function. So we're going to do negative 2 to the second, which is 4. I need to zoom on this a little bit so I can see what in the world I'm doing. Then negative 1 to the second is 1. 0 to the second is 0. 1 to the second is 1. And 2 to the second is 4. Okay, now go ahead and plot those points. So you'll go left 2, up 4, left 1, up 1, 0, 0, 1, 1, 2, 4. So that is the elementary function that we call the squaring function. So just go ahead and get that put in, and then you want to label that. Go ahead and label that as f of x equals x to the second. Okay, now what we're going to do is this 2, what that does is that's really 2 times x squared. So what we do is we multiply the y value by 2. So you're going to take all these y values that we got and you're going to double them. So we just do 2 times 4 is 8. 2 times 1 is 2. 2 times 0 is 0. 2 times 1 is 2. And then 2 times 4 is 8. Okay, so all we're doing is just doubling those values. Now again, you want to go ahead and plot these points. Okay, like this. So we have the point negative 2, 8, which would be way up here. We have the point negative 1, 2. Still have 0, 0. We have 1, 2. And then finally we have 2, 8. So if you go through and do that, and connect that, well, something's happened. It hasn't moved up, it has stretched this. So think of that, think of this red graph kind of like a rubber band, and if you're pulling up on that, you're stretching that. Those y values get bigger, they get doubled, so it's stretched. So what we call this is we call this a vertical stretch. And you have to say vertical stretch. You can't just say stretch. You got to tell me which way. Vertical's up or down. So that's a vertical stretch by 2. Okay, that's what that transformation would be. And that's because of the size of that number. And again, that's outside. What you're going to kind of learn on this is you're outside of the function. You're outside of the squaring. And the y's get bigger. So anytime the y values get bigger, by multiplying, then you're going to do a vertical switch, vertical stretch. Okay, that's the idea. All right, let's go to the next page. All right, so what I'm going to have you all do is work this one out. Now, this is the same thing, except we're going to multiply by a half. And that does something a little different. So I'm going to go ahead and tell you what numbers to use on this. Now, you're doing a third root. It's okay to do a third root of a negative. It's okay to do a third root of 0. It's okay to do a third root of a positive. So I'm going to suggest you use these numbers. Negative 8, because the cube root of negative 8 turns out to be a whole number. Then use -1, 0, 1, and 8. Go ahead and fill these out, and then do those two graphs and see kind of what you think it's doing. See if you can figure out how you would describe that transformation. Okay, so this is what your computation should have come up with. First of all, if you do the cube root of each of these numbers, you get -2, -1, 0, 1, and 2. And if you graph these points, -8, -2, -1, -1, graph these points, you get this red graph. Now what's happening is this 1/2, all it's doing is it's multiplying the result of that cube root, which is this column, by a half. So you're taking half of each number. If you take half of -2, you get -1. If you take half of -1, you get -1/2. Half of 0 is still 0. Half of 1 is a half. And then half of 2 is 2 over 2, or 1. So if you plot these points, it kind of looks like that graph flattened out. It's not like the last problem where it's stretched. It's more like it flattened out. So what we call this is a vertical shrink by a factor of a half. Okay, so what I'm going to ask you for a minute just to think about is, what is the difference between the problem I did and the problem I had you do? Well, if you look at the key difference in these problems, it all depends on the size of that number. That was a 2x squared. That caused it to stretch because the y values got bigger. See how those y values all got doubled? This is a half, which caused those y values to get smaller. So since they got smaller, that's what causes it to shrink. That's how I remember that. And again, you don't want to memorize this stuff. It's just too much to memorize. It's nonsense to try to learn math by memorizing a bunch of stuff. You got to understand it. That's how I remember all this stuff. I understand the underlying arithmetic, the principles behind this. You want to try to do the same thing. All right, think about that. Okay, so here's kind of how this works then. So stretching and shrinking, what we've looked at so far is if this number's outside. So that's outside the function. All right. On the last two examples, that was outside of the elementary function. So if this number is greater than 1, the y values get bigger, therefore it vertically stretches. If this value of a is a fraction between 0 and 1, the y values get smaller, therefore it shrinks. Okay, that's the idea. Think about that. All right, now what we're going to do next is some stretching and shrinking inside the function. So I'm going to go ahead and work this one out and then let you try to work one of these out yourself. So this one we're doing absolute value of 2x. Putting that 2 inside the function is going to cause something a little different to happen. So what I'm going to do is I'm going to do the absolute value of each one of these numbers. Okay, so that's just going to be 2, 1, 0, 1, and 2 like that. So I have -2, 2, -1, 1, 0, 0, 1, 1, and then 2, 2 like that. Okay, so that is the basic elementary function that we've learned how to do. So just go ahead and sketch that in. Be sure you always put those double arrows at the end and then label that as f of x equals absolute value of x. So what we're going to do is we're going to do some number crunching now. So what we're doing is we're plugging the x value in. So see that -2 is going to plug in there. So we're going to work out this. We're going to do 2 times -2, then do the absolute value. And we're going to do that over and over again. You plug the -1 in, you're going to have absolute value of 2 times -1, absolute value of 2 times 0, absolute value of 2 times 1, and so forth. Okay, so that's what you're doing on that basically, is plugging those numbers in. Then we're going to do arithmetic. Okay, so this works like this. This would be absolute value of -4, so that's 4. This is absolute value of -2, so that's 2. This is absolute value of 0 is 0. Absolute value of 2 is 2. And then absolute value of 4 is 4. Okay, so see what we're doing is we're doubling this number. We're changing the x value. We're doubling it, then taking the absolute value. Now if we go through and plot these points, that's the x, this is the new transform y. Let's see if we can figure out what happens. So we have a point -2, 4, -1, 2, still have 0, 0, 1, 2, and then we have 2, 4. Okay, like that. All right, so if I go through and do the graphing on this now, that'll just be a line, kind of like that. And another line like that has that V shape like that. And then let's label that as f of x equals absolute value of 2x. Okay, now let's think about what happened on this problem. There's two ways to look at it. There's two ways, and either answer is correct. We could say it's a vertical stretch. You can see if you pull on the y values get bigger. So we could say it's a vertical stretch by 2, okay, like that. But you could also think of horizontal. Think of like, what do they call those, a squeeze box, an accordion, yeah, an accordion. So you kind of think of this as you're squeezing on it, okay? So you could also say this is a horizontal shrink. Now that's all you got to say is vertical stretch, horizontal shrink. You don't have to say by what factor. That doesn't make any difference to me. So if you just say one of those two, it's okay. All right. And see, those things are always opposite. If it vertically stretches, then it also horizontally shrinks. If it vertically shrinks, then it horizontally stretches. They're opposite of each other. That's the way that's going to work out. And it's going to turn out, it all depends on whether it's inside or out. Okay. So that's kind of what happens on this then. All right. So let's go through. I'm going to have you work this one out. Now, this is the same thing, except we're putting a fractional value inside of that. So go ahead and move down here and pause and then see if you can get this next one worked out. I am going to say this too. I didn't put this, but just go ahead and use these same values and that will be sufficient. Okay. Okay, so let's go ahead and check this and see if you came up with the same conclusion your teacher did. All right, so the first thing, of course, is the absolute value function. You want to make sure you have those y values, and make sure you have this red graph that I've used there. That's the absolute value of x. Now, what happens is when you plug stuff in, like if you plug in the -2, you're doing 1/2 times -2, then doing the absolute value. So that's the absolute value at -1, so it's 1. So all you're doing really is taking half of this number and then taking its absolute value. That's why we end up with positive values. So half of 1 is half of 0 is 0, half of 1 is a half, and so forth. So you can see what I did on each one of those. So that's what happens. So what happened on this, you can think of it two ways. You can think of this red graph flattening. That would be what we call a vertical shrink. Okay, the y values get smaller. If y values get smaller, that's a vertical shrink. Or you can think of it this way, stretch. Okay, if you pull on that red graph, okay, then it will stretch it out. So you could also think of it as a horizontal stretch. So that's how that works out then. All right. So pause if you need to rework anything on that. Otherwise, I'm going to move to the next page, and then we're going to do one more thing to kind of wrap this up here. So what this says is if you're inside the function, okay, if this number is greater than 1, then that'll be a horizontal shrink. An example of that would be this one. That was a horizontal shrink because the 2 was inside the function. Notice that the red graph shrunk to make the green graph. And if this is a fractional value, then it's a horizontal stretch. Okay, so that kind of summarizes this. Again, you're inside the function. If that value of a is a fraction, then you end up having a horizontal stretch. Okay, all right, I think of this as x values get smaller. I think of this as x values get bigger. That's how I remember that. Try to think about that a little bit. All right, so I'm going to have you do one more thing. I want you to go ahead and fill in these things, okay, think what I'm wanting you to answer is, do the y's or x's get bigger or smaller? And and name that transformation then. Okay, so a couple of things I want to note on this. This is outside. So if it's outside, it's affecting y values. Okay, and then these two right here, the transformation is inside. If it's inside, it's affecting x values. So go ahead and pause the video and see if you can get these put together. Okay, so this is what you should have come up with. I think the ones that are always hardest for students to understand is the inside, and it always kind of does opposite of what you think it's going to do. I think that's what happens a lot. Okay, this one, see that 2 is making y values double, so it's getting bigger. Okay, if y values get bigger, then the graph vertically stretches. Okay, this is causing the y values to divide by 4. If you multiply by a fourth, you're dividing by 4. They get smaller, therefore the graph vertically shrinks. Okay, now this is where it's backwards on this. Now this one, you're making the x value get bigger because you're multiplying x by 4. So it gets bigger, so you might say horizontal stretch. No, it's shrink. It's backwards of what you think. If you didn't get this one, look at the graphs we did. Okay, compare this graph to this graph up here. See, the x value got bigger, but however, what happened is it caused this thing to horizontally shrink. That's backwards of the way it seems. I understand that too. Sometimes that's tricky for people to catch on to. Okay, this next one, if you multiply x by half, it gets smaller. So instead of shrinking, it actually stretches. When you start affecting x values, it changes things in a little bit different way. All right, so that will be the end of that part. And then the separate video, what we'll try to do is put all this together. All right.